Now let's consider the graphs of the sine, the cosine, and the tangent function. Remember that the sine is defined as the y-coordinate on a unit circle. The cosine is the x-coordinate, and the tangent is y over x. Just using theta from 0 to pi by pi over 4, we see that the sine of theta, well, let's look at the circle. Okay, if theta equals 0, that's this position corresponding to y equals 0. If theta is pi over 4 corresponding to 45 degrees, then theta is the square root of 2 divided by 2. I've used the decimal approximation 0.71 because when we do the graphing we're going to think of a decimal approximation. But of course we know that the accurate value here is the square root of 2 over 2, and hopefully you remember how to derive that from your 45-degree triangle. Two sides are equal, they add up as a hypotenuse and so forth. Okay? Now, this picture depicts the 45-degree or pi over 4 angle, the pi over 2, the 3 pi over 4, and the pi angle. And we have the projections of the 45-degree points. The projection is 0.71 on the y-axis for either of these points. If we had gone down into the third and fourth quadrant, we'd have negative 0.71 for the projection down here. But the y-coordinates are either going to be positive 0.71 or negative 0.71 for all the multiples of pi over 4 that don't coincide with the two coordinate axes. The x projections, 0.71 here, negative 0.71 here, are going to be the cosine values. So we can see from this picture how to get the sine and cosine values. And I'm not going to spend a lot of time on those because what we really want to talk about is what happens to the tangent. Now the tangent is going to be y over x. At an angle of 0, we're here and y is 0 and x is 1. 0 divided by 1 is 0. So the tangent is 0. When we're here, the y and the x are equal, so that we divide them, we get 1. Now when we get here, y is 1 and x is 0, we can't divide y by x. It's undefined. So we ask what happens as we get closer and closer to this point. Now the closer we get, the smaller x gets. Y comes up pretty close to 1 and kind of stays there. It keeps getting a little bit closer, but it stays real close to 1. So what we're doing is we're dividing a y that stays near 1 by an x that shrinks down as close to 0 as we like. How many times will this shrinking x go into this y? Well, shrink it down as far as we want. We can get this as big as we want. We can get the quotient y over x as large as we want. So we say that the quotient approaches infinity. Now we ask what happens on the other side here. Okay, what are the values of the tangent function when we go on the other side of the y-axis? Well, we see that the same thing happens. The x's keep shrinking down to 0 and y goes toward 1. But of course the x in this case is negative, so we're dividing a positive y by a negative x. We're going to get a negative result. So immediately upon crossing over here, the x's become negative and our tangent values become negative. And as we approach pi over 2 from the left, from the second quadrant, they approach negative infinity. Now, at this point we of course get negative 1, and here we get 0 at these two values of theta. So this is kind of a picture of what happens to our tangent function. If we draw a graph of the tangent function, you can check your text on this, we get a graph that looks like this. We have this vertical asymptote at pi over 2 corresponding to the values of the tangent that approach infinity at pi over 2. And at negative pi over 2, which I haven't labeled, they approach negative infinity. As the tangent function goes through the origin, its slope should actually be 1. And that doesn't look much like it, but then I haven't specified what the scale is here.